Hello, this is my video for Interactive Notebook Check 3, and then I've taken my pages out of the binder just to make it a little easier this time. So for the first one, I have glaciers, and then down here I have all of these with their corresponding letters beside it. And then for the erosion label, I have it in pink, and the letters are C, F, H, J, I, B, and A. And then for deposition, I have it in purple, and G, D, and E are the corresponding letters. For the next one, I have index fossils, and to answer the questions, for question 1, I said layer I because it is below the trilobite. For number 2, I said C. Most of its fossils were aquatic. For number 3, I said site C was once covered by water, so many fossils would have eroded and washed away. For number 4, I said layer D, specifically O, matches with layer B. L over here, they correspond with each other. And number 5, I said igneous rocks do not house fossils for that answer. And then I have all of the little tabs with their letters. For the next one, I have types of fossils, and then I have all the little index cards in their pouches. For carbon films, I said that the whole thing is there and it's reduced to its elemental carbon. For cast, I said there's no animal, just a representation. For trace fossils, I said it can be tracks or fossilized poop. For petrified fossil, I said it is a complete replacement or complete cell replacement. For preserved remains, it's in amber or something else that will save it or preserve it. For a mold, it is an animal that has been pressed into the ground and just an imprint is left. For the next page, I have why does Earth look like it does? And for uniformitarianism, I have the quote, "The present is key to the past" by James Hutton. Earth is formed by a slow natural process, and everything that was happening is still happening today. And then catastrophism, Earth is only 5,650 years old. The exact date for that was October 23rd, 4004 BC. It's based on biblical evidence. The landforms are based on catastrophic events, and then this is by Bishop Ussher. And then for modern geology, the happy medium is Harlan Brett's erosion, floods, and mountain building processes has shaped the land, and it's an ever-changing process. It's not concrete like these two explained. For the next one, this one got kind of messed up in my binder, but I have the geological time, and I have all, let me try to zoom in here. I have all of the different time periods corresponding with the different colors, and I put little letter labels on there just to show it better. And then I have the different periods here, and then obviously the age of fishes, the age of reptiles, and then modern mammals. And then down here, I have all my calculations for the geological time scale over here. And then, of course, my goalposts right there. The next page that I have is types of clouds, and I didn't have, let me scoot that up. I didn't have any tabs to put over these little flaps, so I just glued them above or beside the clouds. But up here we have thin white wispy mare's tail formed in cold air ice crystals. Over here we have cloud layer that sun may be visible through but will appear blurred or fuzzy. Gray cloud producing precipitation formed from altostratus cloud. Down here we have gray layer cloud thick enough to completely hide sun from view. Over here we have separate patches of cloud or waves of cloud. Then we have resemble balls of cotton low enough to have 3D appearance. Over here we have thunderstorm cloud producing precipitation and sometimes hail. And then here we have separate cloud elements about the size of a fingernail when hand held at arm's length. And then down here I wrote clouds can be classified by the altitude, water delivery, and contents of it. So there is that. And then I put all of their names underneath of their definitions. For the next one, we have layers of the atmosphere. So I just put Earth on the back of this one. And then for the troposphere, we have heated from Earth's re-radiated heat, 15 degrees Celsius to negative 49 degrees Celsius. As the altitude goes up, the temperature goes down, and it houses weather. And then I put also the distance here from one of the labs that we did, and then it shows that clouds are here. And then in the stratosphere, it can have volcanic ash and gas there, and it'll stay there for a really long time. When the temperature, or when the altitude goes up, the temperature goes up because of the ozone layer. The ozone absorbs the UV rays. The sun is the direct heat source for this layer, and then it is stable. And then I also put that the tropopause is like in the middle of these two. And then I put the world record made in 2014 when someone parachuted from this height. The next one is the mesosphere, and then I put that it was protection from meteors. It pretty much destroys it before it can get to us. The stratosphere is the heat source for this one. Temperatures go down when altitude goes up. This layer is really, really cold. It said that it could be negative 90 degrees Celsius. It has a low air density, and then few gas molecules to absorb sun's radiation. That's why it's so cold. And then I put the stratopause right here. The thermosphere, there is low density, cold air. Gas is extremely thinly distributed, and then people live here inside space stations, and then obviously the space shuttles go through here. And then I put the temperature and the distance in the mesopause here. And then lastly, we have the exosphere, and then I put the little satellite label here. And I put that there's no real outer limit to this layer. Gas molecules are so scarce that eventually there are none. And then solar wind is here beyond the atmosphere, and then the thermopause. And then just some little notes I put were the northern lights. When massive solar storms cause the Van Allen belts to overload, it's in the ionosphere. And then I labeled the 4 pauses. And then the atmosphere is divided based on temperature variations. The next one that we have is the weather instruments. First we have the weather balloon, a balloon that carries instruments to high altitudes. It measures atmospheric pressure, temperature, humidity, and wind speed. For thermometer, we have tool to measure temperature. In the old style, it uses mercury that expands with increasing temperatures. And then we have the compass. It's an instrument that tells us direction, and then I put north, east, south, and west, and then the needle is directed by Earth's magnetic field. For barometer, it's a tool used to measure atmospheric pressure. Now they are mostly digital, but if they are like the physical ones, it could contain water, air, or mercury, and then it indicates that a change in weather is coming. And then the anemometer is an instrument that measures wind speed. The next one is the weather symbols, if you can see that title down there. For the big H, we have high pressure. Atmospheric pressure is higher than the surrounding pressure. And as you mentioned, H is for happy weather. So it'll be sunny, nice weather, and it doesn't always mean hot weather just because it is the H. And then for the big L, for low pressure, atmospheric pressure is lower than the surrounding pressure. It will be rainy, cloudy, snowy, or stormy, and then it doesn't always mean cold. For the cold front, it is a cool air mass that replaces a warm air mass. It is low pressure and very dense, and then I drew a little model here that the cool air will go underneath the hot air, and the hot air will be pushed up. And then for the warm front, warm air masses replace a cool air mass, and it's slower than a cold front and less dense. And then A stationary front is a boundary between two air masses, neither of them strong enough to replace the other. That's why one shape is on one side and one shape is on the other side. The next one we have is the hurricane versus tornado one that we had to do on our own. For hurricane, I have the counterclockwise rotation, clear in the center, travels thousands of kilometers, several hundred miles wide. It can last days to weeks. The greatest damage is from water. There's about 10 per year, and it is a single air mass. And then for tornado, I have clockwise or counterclockwise rotation, and it has a debris-filled center. It travels only a few kilometers. It's normally less than 1/4 of a mile wide. It is less than an hour. It can be minutes to hours, or an hour. The greatest damage is from the wind. They give a 10 to 30 minute warning, and they have winds up to 300 miles per hour, and there's 800 to 1,000 per year, and then it has 2 to 3 air masses. And then for both of them, I put that they are strong, and they have strong rotating winds that cause damage, and then hurricanes can actually form tornadoes. Okay, the next one I have is world climates. For temperate continental, we have 40 degrees to 70 degrees north. We have the average highest temp of 50 degrees Fahrenheit, and the coolest being 27 degrees Fahrenheit. For winter, it's cold and stormy, and there is snowfall. There's an abundance of trees, and then they are not in the southern hemisphere. For polar, it is continents that border the Arctic Ocean. In winter, it's really dark and really, really cold. For summer, it's still cold, but the days are longer, but the sun is closer to the horizon. It doesn't really get up like we see our sun. The warmest temperature is 50 degrees Fahrenheit, and it is kind of a dry area. There's less than 25 centimeters of rainfall. For temperate marine, we have the sea breeze, cools it off. There's frequent clouds, cool summers and mild winters. There's no dry seasons. The coldest month is has an average temperature of 32 degrees Fahrenheit. There's high humidity, and then about 750 millimeters of rainfall. For the highlands, we have microclimates within this climate, and there's lower temperatures as we go up. There's larger temperature fluctuations. As elevation goes up, temperature goes down. In the lower levels, it can be humid and warmer than the higher levels, and then with altitude, there is more rainfall. For dry climates, we have, there's not a lot of vegetation, but the stuff that is there is well adapted. Oops, let me move that up. High latitudes show rain shadows. Low latitude deserts show high pressure. There are years of drought and then a little bit of rainfall following that. The dry climates make up about 26% of the world's land. There's less precipitation than evaporation. There's abundant sunshine. Winters are cooler and longer than in tropical climates. There's hot summers and irregular rainfall. And then for tropical climates, it is 15 to 20 degrees north and south of the equator. There's always intense sunlight. Each month has an average temperature of 64 degrees Fahrenheit at least. There is abundant rainfall, about 150 centimeters per year, or 59 inches. And then there's an abundance of rainforest. And then up here at the top, I just put the answer to one of the questions that you mentioned. Why is there no temperate continental in the southern hemisphere? And it's because there's no large continental masses. The next one is climate factors. So on the temperature side, we have latitude, less direct sunlight as you get closer to the poles. Altitude, air temperature will decrease with height in the troposphere, and then polarity to water. And then for precipitation, the prevailing winds form over the water or land, and they will pick up the moisture. The mountains, rain shadow effect, air masses have to go up and over the mountain range, and so it will drop the moisture that it has picked up. And then seasonal winds like the Indian monsoons. And then for the last page, we have the weather flip book, and I didn't see this one in the video, but it was in my packet that I got, so I just went ahead and did it. For the first tab, we have what are the current weather conditions in Denver, and I said snowy, very cold, icy, and cloudy. What are the current weather conditions in New York City? I said high pressure, sunny, clear weather because of that high pressure. And then what will you expect to happen to the weather conditions in Houston and Chicago in 1 to 2 days? And I said potential snow and much colder temperatures because of the cold front moving in. For the next day, predict the weather in Houston and Orlando for the next couple of days. And I said the stationary front depicts rain for a few days since it's already there. Describe the weather in Chicago today compared to yesterday, and I said that it is warmer than before, possibly partly cloudy. And then what is the weather in Seattle? I said since the high pressure, it's sunny, clear, good weather. And then for my own weather map, I put high pressure zones over kind of near Seattle and New York. And then I put low pressure zones kind of near Denver and then just north of it. And then I put a cold front coming in and then some sunshine and clouds down here. And then just a little description. I said Seattle will have warm, sunny weather and clear skies because of the high pressure over here. And then Denver and Chicago will experience cold, stormy, and or snowy weather soon since this will be moving in. And then New York will be experiencing clear skies and sunny weather since that high pressure zone is over here. Thank you.